This problem. We got to be really careful, and I want to do a couple of these. This is like number 7 and 8. From the practice set, okay? What if they already give you an interval? And I want you to rewrite it in polar coordinates. So here you go. Like, I'm really going to mess around with this thing. Just so you become an expert. 0 square root of 16 minus x squared. I'll just write sine of x. dy. You don't have to solve this problem. I just want you to rewrite this in polar. Rewrite it in polar. So this problem like 7 and 8 off the practice set. Can you just rewrite this whole thing in polar? Well, people just assume, oh, it's going to be a full 0 to 2 pi and stuff. We got to be very careful. I know you're going to put down your already theta, right? I know you know what to put in place of that x. What are you going to put in place of that x? Arc cosine theta. Be careful with this. What is that representing? Is that a full disk? Is that just half of a disk? Or is that a quarter of a disk? So let's look at this carefully. Remember how I wrote it before? I'm going to do it again. Shade between, right? Just as a reminder, what are we shading? Shade between these two curves. Go from this number to this one, right? So is that a top semi or a sideways? One on the side?
Side, this one.
What do y'all think? That's y equal to this. Is that a top semicircle like this? Or is that one of these on the side? It's a top one, so I'm going to draw this. Let's draw that radius integration. So it's a top semicircle. What's the radius? 4. But where am I shading? Shade between these from where to where?
0 to 4.
My worry is on a test or the problem set that just shade too much. It's saying only shade from what? Look, shade between the top and the bottom, but only from
0.
x equals, start here. Oh. So what do y'all think? When I do theta, what do you think theta is going to be? Is it 0 to pi over 2, 0 to 2 pi, 0 to 3 pi over 2? 0 to pi over 2. Right? The radius is easy. What's the radius going to be? 0 to what? 0 to 4, 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 0 to 4. Sine of, what's this become? R times.
Cosine theta.
Now look it over. Did I forget anything?
Yeah, R.
Thank you. You're doing good. I'm telling you, you can imagine how many times on a test I had to go. You forgot the R. Oh, you forgot the R. Oh. So you can put it anywhere. You can put it here. I put it out in front just to let it stand out. There it is. R times sine of all that. 0 to 4, 0 to power 2. Now, can I play with those? How would this affect a problem? So now I'm going to start playing. I want you to become an expert. And I'll wait if you write all this down. I don't want to rush it. How would that change? Okay, you would shade from here to here. Now this just changes to what?
Pi.
Pi. So I need you to really study that carefully, okay? Don't just assume it's 0 to 2 pi. Let me do one more, and I think you're an expert. What if I had this? Negative squares. Now what do you got? What's the bottom curve?
Sine, so 2 pi.
And you're going from negative 4 all the way to 4. 0 to 1.
2 pi.
Is that what I'm saying? And you asked me a good question yesterday. Brad, I was thinking when you go, can't we just double stuff and triple? Well, we have no knowledge of that surface. So we don't know if that surface is what? having the same type of shape over this region and this region, so we can't assume that. Right? That's why we gotta make sure we just get all that set up properly. Is that okay with that? Hey. Try this one. Okay. See, they all look the same, don't they? They definitely do. Can you put that in color? We have to, sorry, I just need to set it up. Put that in color. Take your time too. Go Polar! Already theta, right? What's this become? R sine theta. So R times R sine theta is what?
R squared.
R squared sine theta. What's this stuff? Can you help me draw that? It's all about that drawing. What are these, X's or Y's? Ooh, good, this is Y, this is Y. Go from -2 to 2, where is that semicircle? On the side, so it's over here. Showing right side, shade between the right, and shade between the left. What's the left wall? X equals 0, right? And how far are you going from? From -2 to 2. What's your step? -pi/2 to pi/2, and what's the radii? Good job. By the way, I've seen this sometimes on test too. You will never get an R that's negative there in your limits of integration. Never. It's always going to be what? 0 to 2, unless it's a donut. If it's a donut, it could be like 1 to 2, right? You know what I mean by a donut? Like just a portion like this. You go, oh yeah, 1 to 2, 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 1 to 2. Once again, that's another place where just dealing with a donut portion, where polar coordinates is really helpful. Cool. Good job. Can't raise. Okay, let's do another one of these. Ready? So what I want you to find the integral of the function f of xy equals 10, or excuse me, 20 over 1 plus x squared plus y squared over a disk of radius 3. Center of the orbit. Can you set that up? Why would I want polar coordinates? Is that what's in it? Right there. If I'm going to find the integral of this over a disk of radius 3 centered at the origin, I'm going polar. Already theta. What would this become? 20 over 1 plus, what do you think?
R plus
R
theta.
squared. Full disk, what would theta be? You don't even have to draw it. What's a full disk? Full disk, 0 to 2 pi. What's this though? 0 to 3? We don't have to draw that thing. It's a full disk, radius of 3. But how do you do that interval? That's why I wanted to work this problem with you. I didn't want you to get stuck working a problem off the practice set and stuff. It's 20 times r over 1 plus r squared. How do you do that?
Partial integration or something?
It's a u sum. You know how I know it's a u sum?
Because of power.
Higher, great eye. He goes, the higher power on the bottom is a difference of 1. You see that?
Yeah.
So this is a u sum. I'm going to let u equal to 1 plus r squared. That was my real purpose of doing the problem with you. I know you could have set this up properly. I wanted you to be able to deal with the integration method. Like, is that integration by parts? Or is that partial fractions? Is that a trig substitution? You're like, it's just a u sub. 2r dr. So 1/2 du equals
RDR.
r dr. Pi by r dr. See what happens there, Art, and everyone, if the student forgets to put the r, then they're thrown off. Because they don't know how to, it's like, how do you do this integral? Is that an arctan? What is that? I'm thinking that's an arctan problem, right? That's what that integral looks like, but it's a u sum. So I'll go back in here. Hey, while I'm doing this, can I break these up? Yes, I can I? I'm going to do it. All right, so you got a 0 to 2 pi of a d theta. What's that just going to turn into?
Theta.
That's just going to turn into theta, but that's going to be 2 pi. That'll be a theta, go from 2 pi to 0, subtract them, right? So all you're dealing with now is this 0 to 3 of the 20 over 1 plus r squared. So I'm going to put the 20 up in front. Now what do I have to divide from the 20? This 2. Remember last time I forgot it? It's like, don't forget. 20 times a half. This is now u. What's in the numerator now? Just 1.
1.
What's the integral of 1 over u?
None.
ln. And 20 over 2 is a what? So I'm going to get 10 natural log of u. I'm going to resubstitute. What was u? 10 natural log of... Where were the limits? Are they there? 0 to 3, 1 plus r squared. Hey, you don't need bars for anywhere. Isn't 1 plus r squared always positive? Yeah. So what's 2 pi times 10 times down to 1 plus r squared from 2 to 0? What do you get? I get 20 pi times natural log of 10 minus natural log of 1. Done. What's the natural log of 1 now?
0, right?
0. So you don't have to write this. Here's 20 pi natural log 10. You got polar coordinates now. Hey, I'm going to introduce this section right now. Center of mass. The center of mass of something in the xy plane. Everyone, this could be some kind of lamina. We're going to write it as the coordinate x bar, comma y bar. With the x with a bar over it and y with a bar, we'll call it x bar, y bar. That'll be the center of mass. But we need a formula for that. Well, double integrals in polar coordinates. We know with double integrals in polar coordinates, we just did what? I'll resolve this. In polar coordinates, we said this. Double integrals in polar coordinates. We said function of x and y, dA turned into function of r cos theta, r sine theta. I put down the letter r, right? Automatic? You already did. Isn't that what happens? Every time we say these are equivalent. Well, what's the math formula for finding this center mass? Well, let's start with just the mass. And the mass will be equal to just over some region D. Let D represent that lamina. When I say lamina, I'm talking about just a very thin plate. Right? It could almost be as thin as this piece of paper. That's what I'm talking about, a lamina. So very, very, very thin, like a thin plate. And all we need to do is take the double integral of the density function. So when I just introduced the Greek letter rho, that's the Greek letter rho. Let rho of xy be the density function. Okay, so that's mass. But how could you find the x bar, which would be the x coordinate of the center mass? All right, to do that, everyone, we got to do two double integrals. You got to find this one. And this will be the x bar. X bar would be divide out that mass. So let's call the mass m. Divide out the mass and do the double integral of. Well, I'll write it this first. They call this the moment about the y-axis. Let me write it that way first. X bar is equal to 1 divided by mass times the moment about the y-axis. Because if you've got a y-axis, you're talking about the average x values, you're going this way or this way. We're just taking the average of these distances here. Right? For an x bar, for an average x. And that's why we call it the moment about the y-axis. Well, this turns into 1 over m times the double integral of the density function. Bless you. But you got to include this letter. So x bar, just put an x right there. That's the formula we're going to use to find the x bar. So do you notice it will involve two double integrals? Because to find m, you got to do what? That's the mass. You got to do this. It doesn't have the letter x, but if you have an x bar, you got to get this double integral of x times the density function divided by the mass.